Welcome, welcome. So I am now on page 6 of our first note packet. And so the purpose of this short video is just to introduce some basic probability rules that we will then apply more in class. Um, and so to start, there are these three what are called axioms of probability. And so these are uh, some just fundamental facts that we will use to kind of build these other probability rules. I think most of them are fairly intuitive, so probabilities have to be between 0 and 1 inclusive, so that's what this first axiom says. This second axiom says that if you wrote down all of the possible outcomes of an experiment, so you could kind of think of like rolling a six-sided dice or die, for example. Um, all of the possible outcomes in rolling a six-sided die, or you could roll a 1, a 2, a 3, a 4, a 5, a 6. Those make up this set S, which is called the sample space. And the probability of something in that sample space occurring is 1. A consequence of that is that the probability of this null set, which has this little symbol phi, and so we're calling this our null set, so the probability of that is 0. And then the third axiom says that if we have a bunch of mutually exclusive events, then the probability of their union we could find by just adding up the individual event probabilities. And so events are mutually exclusive. So if, say, A1 intersect A2 is the empty set. So these two events can't occur together. In the die example, you cannot roll a 1 and a 3 at the same time. And so rolling a 1 and rolling a 3 would be mutually exclusive. Okay, so moving into some of these rules then, we'll talk about these four in this video. So the first is the complement rule, which says that we could figure out the probability of a complement, which is written with this little bar symbol on top, by just subtracting the probability of A from 1. And so for each of these, we'll draw a little diagram. And so if this entire box is our sample space, A is this little circle, a complement is anything outside of the circle. This rule really comes from the fact that the probability of S is 1. So you can see if this whole box has probability 1, then we could figure out the probability of A complement by just subtracting the probability of A from 1. We'll use this rule a bit because often it will be easier to think about finding the probability of A complement instead of the probability of A. The second rule is this additive rule. And so again, we'll draw a little diagram where S is our sample space, and that's this whole box. We'll say A is this little circle, B is this little circle. Probably jealous, as you can tell, I can draw perfect circles every single time. So, one of my many talents. And so what this rule says is to find the probability of A or B, what we could do is add the probabilities of A with the probability of B, but subtract off their intersection, because if we didn't do that, we would be double counting this area right in the middle that I'm shading in. So doing this subtraction adjusts for double counting of A and B. So that is our second rule, which we're calling the additive rule. And then really these last two are kind of the same rule. But this definition of conditional probability, and so again we'll draw a little sample space. We'll again do a little circle for A, a little circle for B. Yikes. And what this rule says is it gives us a formula to calculate what's called the probability of A given B has occurred. And so it says that, okay, suppose that event B, it's happened. So whatever it is, it's occurred. We know that it's happened, and so we know that now essentially our new sample space, because we know B has happened, is this green shaded area that I have just shaded in. Given that B has happened, what's the probability of A? And so if this is our new sample space, the probability of A is just this intersection divided by our new sample space, so the probability of B. And so that's kind of where this formula comes from. Essentially, we're taking the intersection and dividing by the probability of that B happens in the first place. This last rule, and so we'll use this conditional probability rule like a ton, so we'll get lots of applications in. This last rule is really just a rewrite of the conditional probability. So we're not really even going to talk about it. So it just rearranges the conditional probability definition. So, it gets lumped in here, but it's barely qualifies as a rule because it's the same as the conditional probability definition, just rearranged algebraically. Okay, so we will see lots of applications of these rules in class and see how they can be combined to solve some more complex problems as well.